Hi, this is Dana Gardner, Principal Analyst at Inter Arbor Solutions, and you're listening to BriefingsDirect. Thinking of IT security as a fortress or a moat around your compute assets has now given way to a more realistic and pervasive posture. A cybersecurity perimeter, it turns out, was an illusion. A more effective extended enterprise strategy protects business assets and processes wherever they are and wherever they might reach. As businesses align to new approaches such as zero trust and behaviors modeling to secure their data, applications, infrastructure, and networks, there's another rapidly expanding digital domain that needs modern protection. Stay with us now as we explore how APIs, microservices, and cloud-native computing in general form a new frontier for cybersecurity vulnerabilities, as well as opportunities for innovative defenses and resilience. To learn more about why your expanding use of APIs may be the new weak link in your digital business ecosystem, please join me now in welcoming our special guest. We're here with Jyoti Bansal. He's Chief Executive Officer and co-founder at Traceable AI. Welcome, Jyoti.
Thank you, Dana. Very excited to be here.
Yeah, we're glad to have you. So, Jyoti, how has this global explosion of cloud-native apps and services set us up for a new variety of security vulnerability? How serious is this new level of vulnerability?
Well, it's definitely new and it's quite serious. If you look at every time we go through this change in architectures, we get a new set of security challenges. The adoption of cloud native architectures creates challenges around a few things. One is you have lots of APIs and you have APIs as kind of your doors and entryways in your systems and your apps. And if those are not secured properly, you have more opportunities for attackers to steal data from it. You open the APIs so that you can expose data, but attackers will try to exploit it, and we are seeing more and more examples of those happening. The second major challenge that is happening is with this cloud-native apps is also the development model. The development model is much more high velocity, is much more agile. As people are using DevOps and CI/CD, and what that creates is its velocity of you're changing things once every hour, maybe even, or sometimes even more, right? So that creates these kind of opportunities for developers to make mistakes in their apps and in their APIs, and how they design a microservice or how different microservices or APIs are interacting with each other. And that creates a lot more opportunities for attackers to exploit.
So companies, of course, under a lot of pressure to do things quickly and to react to a very dynamic environment. But at the same time, you have to always cover your backside, as it were, with security. So how do companies factor the tension between speed and safety?
Yeah, and that's the biggest tension in many ways. You are forced to move fast. Speed is important. The pandemic was even more of a challenge for a lot of companies, that they had to move to more of a digital experience much faster than they imagined they would, right? So the speed was even more prominent. So speed creates a challenge around safety, right? So which is speed creates two main things. One is that you have opportunity to make mistakes. If you ask people to do something very fast because there's too much pressure, business pressure, consumer pressure to do things, sometimes you will cut corners and you will make mistakes, and not deliberately. It's software engineers would never write bug-free code, right? So if you have more bugs in your code because you are moving very, very fast, it creates a challenge, right? So how do you create safety around it? Is by trying to catch these kind of security bugs and issues much earlier in your software development lifecycle. So if they have challenges around a developer created a new API, and that API could be exploited by a hacker, and because there is a bug in that API around security authentication check or authorization check, etc., you have to try to find it in your testing cycle and your SDLC cycle, right? Mm-hmm. The second way you do safety is by creating a safety net. Even if you try to find things earlier in your SDLC cycle, it's impossible to catch everything. It will be the most ideal world that you ship software that has zero vulnerabilities and zero gaps of any kind, when it comes to security. But that doesn't happen, right? So what you do in that case, you have to create a safety net that if you did leave a vulnerability because you had to move fast, and your business was, the business pressure was there to move fast, there is some safety net that can still block the attackers when they're trying to do things that you didn't intend from your APIs and applications.
And another vulnerability, I suppose, is not only do you have to be thinking about the APIs that you're generating internally, but there's a lot of third-party APIs out there around microservices when especially we're doing those extended enterprise processes. So is it a Wild West environment when it comes to these third-party APIs that you also need to think about?
Definitely. You have APIs that you are building as any software engineering team, that are exposed externally. And you have APIs that you are using internally through your microservices that maybe not an external consumer is calling those APIs, but internally other microservices are calling them, and there is an exposure around that. The third-party APIs, they manifest in two different ways. One is that you might be using a third-party API or library in your microservice, and there might be a security gap there. And the second way that manifests is for when you're calling third-party APIs. Almost everything is exposing APIs, and if you want to do, you want to check for some data somewhere, you want to call into some other SaaS service, you want to call into some cloud service, you want to call into some payment service. Everything is an API, right? And if those APIs are not called properly, or those APIs are not secure, your system can fundamentally become insecure. So I would say it's getting close to a wild west in APIs. And I do think people have to take API security quite seriously at this point.
We've been talking about this as a factor of sort of growing pains, that you're moving fast and this isn't a process that you might be used to and you've got third parties involved. But there's also malice out there. We've seen advanced persistent threats in such things as zero-day exploits in Microsoft Exchange servers recently. We've certainly seen with the SolarWinds exploits how a supply chain can be made vulnerable. Have we seen people take advantage of APIs, or is that something that we should expect?
We should definitely expect that. And we are also seeing people taking advantages of these APIs. If you look at data from Gardner has stated by 2022, APIs abuses will move from an infrequent to the most frequent attack vector. And so that will result in more data breaches in enterprise web applications. And that is the new direction where how the applications are consumed through APIs. So the APIs naturally become a more and more of a growing form of attack vector now.
Do you expect, Jody, that this is going to become more critical? I mean, we're sort of through this process of software eats the world, but we're only probably a part of the way into it. And so we expect that software will become more critical, and yet APIs are becoming more part of that. And yet now you're telling us that APIs could be a new massive threat vector.
Definitely. It's we are, as you said, we are, the software eats the world trend is happening, and we are still not fully there. We are only 30-40% there, right? So as we get more towards we will see more and more APIs, and more APIs does create this kind of attack vector. It's really a matter of securing and taking these seriously. For a long time, people didn't think about APIs, right? People thought about APIs as internal APIs, that you will put internal APIs between your code and between different services. And then the external APIs were very few. And most of your users were coming through a web application or a mobile application, and you're not exposing your APIs as much to external applications, right? Like if you look at, for example, a bank, most of the banking software was about, online banking, where the end users are coming through it, or mobile banking, where the end users are coming from mobile apps. They didn't have to worry too much about APIs, to do their business. Now that's not the case. Like for a bank, APIs are a major source of how other systems integrate with them, because, banks don't have to expose their systems just through the apps that they are building, but to a lot of third-party apps that are written on top of their APIs. From wallet kind of apps to different kind of payment systems to all sort of things that are out there, right? Because that's what consumers are looking for. So now as you start doing that, the amount of traffic that's coming through these APIs, not through the web or mobile front ends directly, is significantly increasing, right? Then the other part that's increasing is the internal APIs. Like the internal APIs with the adoption of cloud native and the microservices architectures, the internal boundary is starting to blur too much, right? So the internal APIs could become external at any point, because it's like the same microservice that our engineering team wrote is used by your other internal microservices inside your company, but they're also exposed to your partners or other third-party systems to do something, right? So more and more APIs are being exposed out there. So it's really, we will see this continued explosion of APIs, because that's the nature of how modern software would be built. APIs are the building block of the modern software systems. I think we have two options as the industry. Either say, okay, APIs are could be risky or someone could attack them, so let's not do APIs. But that's, to me, is completely wrong, because APIs are what's driving this flexibility and fluidity in modern software systems and the velocity that we get through it, right? We have to just learn as an industry to secure them and be serious about securing the APIs.
Your role there as a co-founder at Traceable AI is not your first rodeo. You've been a bit of a serial startup in a Silicon Valley tech visionary. Tell us about some of your other major companies, Appdynamics in particular, and why that puts you in a position to recognize the API vulnerability, but also come up with some novel ways of making these more secure and usable.
Yeah, I think it's a good question. I have a unique advantage that I have founded companies to solve big problems like these in the past. Appdynamics was my first company, which I started back in 2008. The purpose of Appdynamics was to really give development teams good solutions to diagnose and troubleshoot when something goes wrong in their distributed software systems. And then that time, we were starting to see a lot of these service-oriented architectures started to come in, and people were struggling with that if something is slow, that my software system is slow, users are experiencing slowdowns from the website. How do you figure out where the slowdown is, and how do you find out the root cause of doing it right? And that space eventually became what is called application performance management, space. And what the approach that we came up with over there was, how about we instrument what's going on inside the code in production, and how about we trace the flow of code from one service to another service to third service to a database, so we can figure out where the slowdown and where the bottleneck is, right? So by understanding what's happening in these complex software systems, you could go and figure out where the performance bottleneck was and where you could slow down things. And we were quite successful as a company. We were acquired by Cisco just a day before we were about to go IPO on Nasdaq in 2017 in doing this. But what I learned there was this kind of the approach that we use at Appdynamics to solve problems around performance monitoring, troubleshooting, diagnostics, that the fundamental approach was about instrumenting and learning what is going on in the system itself, right? That's the same approach we think applies to solving the problems around API security. We have all these challenges around APIs are everywhere. It's wild west of APIs, everything, right? So how do you get in control of those? You don't want to ask developers to go and slow down and not doing APIs or not moving fast enough or reduce the velocity and everything, right? So the way you get control over it is fundamentally a very similar approach that we used at Appdynamics for performance monitoring and troubleshooting, which is by understanding everything. Can we instrument and trace all the APIs that are there? That you put us in our environment, we could understand, these are all the external APIs, these are all the internal APIs, these are all the third-party APIs, how the data flows between different APIs, which users call different APIs, what are they trying to achieve out of it, what APIs would change by developers, which APIs have sensitive data in them, etc. That you automatically understand all of that. Once you have the understanding, the right understanding of what all the APIs are, now you start to get in control of what's there, right? Once you are in control of what's there, you can start learning. Is some user is trying to use these APIs in a bad way? That sounds like an attack, or that seems like something wrong happening. There might be a possibility of they're trying to do a data breach or something. Then you can start going in the prevention mode that you can block that and attack that. So yes, a lot of similarities from my experience at my last company, Appdynamics, in terms of how we can solve challenges around API security. I also started a second company after Appdynamics, a company called Harness. And Harness is in a different space, targeting DevOps and software developers, helping them with CI/CD. And Harness is one of the leading platforms now for CI/CD out there, right? So, I have a lot of experience from that vantage point now, what do modern software engineering organizations have to do from a CI/CD DevOps perspective, and, what security challenges they start running into. And when we talk to Harness customers doing modern CI/CD, application security, API security almost always comes as one big challenge on why they're, worried about microservices, why they're worried about cloud native architectures, why they're worried about moving more APIs, why do they need to get in control of of creating the safety net around all of this.
And this approach of trace, monitor, understand the behavior, understand everything, does that apply to both the internal APIs as well as the third parties and externals? Does it apply to what's going on in operations as well as what goes on in development? Is this a one-size-fits-all solution, or do you have to attack those problems separately with different approaches?
Yeah, that's the beauty of this approach, that it is in many ways one-size-fit-all approach. That how you use the data and the that comes out of this trace everything, instrument everything is different, but fundamentally it does work in all of those, right? So the way this kind of solution work is the engineering teams will have to put in something what we'll call like a lightweight agent. An agent goes inside the runtime of the code itself, right? So like the code running in different programming languages, Java, PHP, Python, or the agents could run in a sort of your your application proxies that you have in your environment, right? You could put the same kind of approach, these kind of instrumentation, lightweight agents that we would have in your, for your external APIs. You can put them into like where your internal microservice APIs are. You could put them where you're calling your third-party APIs, and it's all the same. That we will figure it all out. All you have to drop this kind of instrumentation tracing, and now you can take the same approach. And ideally, you would want to put the same in a pre-production environment, like while you are going through your software testing lifecycle in a CI/CD system, right? So where normally you will go through some testing and then some staging and some load testing, and then you will start putting in production, right? So you want to put the same kind of approach in all of that. The difference would be in the testing cycle, we will tell you based on all the instrumentation and tracing that we are looking at, all the calls that are coming in based on your tests, these are the places that are vulnerable. Like these are the APIs that have these gaps, and these could be exploited by someone. Once you do this same approach in production, we are not only telling you these are the places that are vulnerable, we are also blocking attacks that are happening. We're saying this is the place that is vulnerable, and right now there's an attacker trying to attack this API and steal some data from here, and this is how we can block them as they do it. But it's fundamentally the same approach that could be used across your SDLC lifecycle.
Don't want to put the cart in front of the horse as we talk about the solution, because I'm afraid that there's still a degree of education that's required about how big this problem is and how large it could become. Mm-hmm. So let's go back to this concept of, if we want all the people in these roles, in these personas, be it developer, operations, SecOps, security in a traditional sense, do you have any examples or metrics of where API vulnerabilities have cropped up, and what are the sort of major categories of API vulnerabilities that we're seeing already?
We see API vulnerabilities that have propped up in in many ways. A lot of it is around APIs that are unauthenticated endpoint. You expose an API and doesn't have the right kind of authentication inside it, right? That's definitely one. Second is around not using the right authorization. Like you call an API, and that API is supposed to give you data for you as user one, but the authorization had a flaw that could be exploited for you to take data, not just you as user one, but to get data from someone else, user two, or maybe a large number of users somewhere, right? So that's a very common kind of problem that happens with APIs. You have the APIs that are doing, they're what you will call leaky APIs that are giving you more data than they should expose. An API that's supposed to give you just the name of someone, but when you call the API, it gives you an entire object, which has 10 other fields, which includes more sensitive data, maybe more than just the name X. They're patterns of attacks and threats that are starting to emerge out of in the APIs. In the world of application security, we had the OWASP top 10 list that the app security teams and the security teams have followed for a long time, which is what are the top security threats that they should worry about. And you would normally have things like SQL injection and your cross-site scripting, and those were always in the top in that list. Now there's a parallel list that's starting to come, which is called OWASP API Security Top 10, which starts listing out what are the top threats that are happening when it comes to APIs. And some of the threats that I described are key part of it. And there are a lot of examples of these API involved attacks that are happening these days. I can give you a few examples if you're interested, in the real life impact on it. We just recently, 2020, we had Starbucks, where there was vulnerability in API calls, potentially exposed 100 million customer records. It was around an authentication vulnerability. We had 2019, Capital One was a high-profile example. There was a AWS configuration API that wasn't secured properly, and an attacker got access to it. It exposed all the AWS resources that Capital One had. There was a very high-profile attack that happened on T-Mobile in 2018, where an API that was leaking more data than it was supposed to. 2.3 million customers' data was stolen around it. Another high-profile attack that happened at Venmo to a public API, which was not exposing the data for the right users. So someone took 200 million transaction data was stolen from Venmo. So you see these kind of examples, and we are starting to see these patterns emerge on what kind of vulnerabilities attackers are starting to exploit in these APIs.
Sure. Now, these level 100 million customers or multiple hundreds of millions of transactions exposed, that's going to get the attention of the very top of any enterprise, especially now where we're seeing GDPR and other regulations that require disclosure of these sorts of breaches and exposures. This is not just a nice to have. This sounds like potentially something that could make or break a company if it's not remediated. And now that you know that it's a risk, you have to think about how to best remediate, right?
Definitely. No one should take API and API security lightly these days. A lot of your traditional cybersecurity teams have put a lot of their focus and energy on securing the networks and the infrastructure. And many of them are just starting to get serious about this next threat vector. And I would say it's a big mistake if the companies that are not getting there faster, they are exposing themselves in a big way.
So I suppose the top lesson for security teams, and they've probably been through this before in other types of security vulnerabilities, is you got to know what's there, you got to protect it, and then they have to begin to be proactive. What is it about the way that you're approaching these problems that sets you up to be able to be proactive rather than reactive over time?
Mm-hmm. You said it right. The fundamentals of security are the same, which is you got to know what is there. You got to protect it, and then you become proactive about it, right? And that's the approach that we take at in our solution at Addressable. Number one is all about API discovery and risk assessment. So you put us there in your environment, and very quickly we'll tell you what are all the APIs. It's all about discovery and inventory as the very first thing. These are all your external APIs. These are all your internal APIs. These are all the third-party APIs that you're invoking. So it starts with discovery. So you got to know what is there, right? And create an inventory of everything. The second part of when you create that inventory is to give them a risk score. So we'll give every API a risk score, internal API, external API, third party, all of them, right? And the risk score will be based on many dimensions that we would use, which APIs have sensitive data flowing through them. Is it potentially PII data versus not? Which APIs are exposed publicly versus not? Which APIs have what kind of authentication into them? What APIs are internally using your critical database systems and reading data from those? So based on all of these factors, we are creating a sort of a risk heat map of all our APIs, right? So that's really the first part of you got to understand, create an inventory, and know what is there. The most important part for APIs to do this, though, is it has to be continuous, because you're living in the world of continuous integration, continuous delivery, CI/CD. So any kind of API discovery or assessment cannot be static, that you do it once a month or once a quarter or even once a week. You have to do it dynamically all the time, because the code is changing. Developers are putting code continuously out there. So the APIs are changing, new microservices, new all of that stuff, right? So all of the discovery and risk assessment has to happen continuously. So that's really the first problem we handle at Addressable, right? The second problem now we handle after that is, once we understand it all, we are building sort of a learning model. The learning model is all about based on a very sophisticated machine learning approach on what is the normal usage behavior of each of these kind of APIs. What are the users that are calling an API, in what sequence they call them, what kind of data they pass through them, what kind of data they are fetching out of them, what APIs are used in what order. If you call an external API, what internal service APIs that API will internally use all of that. Right? So we are learning all of that automatically. And now once you kind of learn that, you start comparing every new API request with what is the normal model of how your APIs are used, right? So if you have an attacker that's trying to use an API to extract much more data than what is normal, that normally people ask for data for one user, and you suddenly have an API call for there where someone is asking you data for 100,000 users. Something is abnormal about it, right? So you could flag it. And that's a key part of how we think of the second part, which is how do you protect these APIs from bad behavior? They cannot be done with the traditional WAF and RASP and those kind of approaches, which are very rule-based or static rule set-based approaches. For APIs, you really have to build a behavioral learning-based system. And that's what our solution is about. And that's how we get to a very high degree of protection for these APIs. Third part, which is the proactive part after that, which is now a lot of this learning, what we also bring it into this, that we, as we're learning the behavior of these APIs and where the potential vulnerabilities are based on the models, the right way to proactively use our system is to feed that into your testing and development cycle. That can you bring it to the developers to fix the vulnerability? There are new vulnerabilities. Can we help find people, earlier in the life cycle? Can you integrate that into the same kind of approach that we're doing in your application security testing process? So it closes the loop on you doing all of this proactively now.
All right. Well, we're about out of time, Jyoti. What should businesses do to prepare themselves at an early stage for API security, and who should be the ones tasked with kicking this off and being, I suppose, sort of the instigator in the organization to take API resiliency seriously? Whose shoulders does this fall on?
It falls under the umbrella of app security. In many businesses, app security teams are now tasked to secure the APIs in addition to the traditional web applications. In many places, we are also seeing businesses started to create these teams around what they call product security. So let's say if you are a company with your fintech products, your product is APIs because your product is primarily exposed through APIs. And then people start building out product security teams who are tasked to secure these APIs. In some cases, we see the engineering teams, the software engineering teams directly responsible for securing APIs. So whatever the model is, I do think the first thing as every business has to do is to create responsibility around securing APIs, right? After that, the next thing that becomes is you have to start by bringing something to understand the inventory. I'm amazed every time I see so many businesses we talk to, they are struggling with just even knowing what APIs are there. When they think of we are still starting to think about how should we secure about our APIs, and we're very worried about it. But the problem is we don't even know what all our APIs are. And we have 2,000 developers or 500 developers in the company, and they build all these APIs and all these things, and we can't even track them. Right? So, most businesses have to start by getting even an understanding and kind of control over the APIs that are there, and so that you can start securing and start getting a better security posture around those.
Well, great. I'm afraid we'll have to leave it there. You've been listening to a sponsored BriefingsDirect discussion on how APIs, microservices, and cloud-native computing may be the new weak link in your expanding digital business ecosystem. And we've learned how modern security strategies of tracing, analyzing, and modeling behaviors provide opportunities for new API defenses and resilience. And so a big thank you to our guest. We've been here with Jyoti Bansal. He's Chief Executive Officer and co-founder at Traceable AI. Thank you so much, Jyoti.
Thank you, Dana.
And a big thank you as well to our audience for joining this BriefingsDirect API protection discussion. I'm Dana Gardner, Principal Analyst at Inner Arbor Solutions, your host throughout this series of Traceable AI-sponsored BriefingsDirect discussions. Stay tuned for our next podcast in this series, again with Jyoti, for a deep dive into ways that APIs can be made more robust in production use as well as in development. Thanks again for listening. Please pass this along to your business community and do come back next time.